Okay, our first trigonometric integral is when we are looking at the first case where the power of sine is odd. If that's the case, so you should be looking at your trigonometric integral summary sheet. For this case, when m is odd, we break sine into, we peel off a sine. So we write sine x times sine squared x. And we replace sine squared x, or whatever even power of sine we have, with the Pythagorean identity 1 minus cosine squared x. You should see the Pythagorean identities should be written on the back of the page. I think maybe they're not, but I can summarize them quickly. The first one is sine squared x plus cosine squared x equals 1, which is the one that we're currently using. The second one is tangent squared x plus 1 equals secant squared x, and 1 plus cotangent squared x equals cosecant squared x. These will be coming up, primarily the first one. So let's get back to our example. We're going to peel off that sine and rewrite this as sine x times sine squared x times cosine squared x dx. And as the instructions say, we're going to substitute for this sine squared 1 minus cosine squared x, which is from the Pythagorean identity. Okay, at this point, we can use a substitution. And let's think about why that may be, right? With a substitution, you want to have a function and the derivative of that function somewhere in the integrand. Well, if I let u be cosine, I know that the derivative of cosine is sine, negative sine, but it's right there. Now, this will give us an expression all in terms of u, which make it a lot easier to do the substitution now. So I'm going to let u be cosine x. So for substitution, remember that we're undoing the chain rule. So du will be negative sine x dx. So we know that sine x dx is negative du. So back in our integral, this sine x here with the dx will be negative du. And I'm going to rewrite this as, when we look at 1 minus cosine squared, that will be 1 minus u squared. I have another cosine squared, so another u squared. And then sine x dx is the negative du, but I pull the negative on the outside. At this point, this is just a matter of doing the power rule. So I'll do it a little bit further, but just because these videos, sometimes the longer they are, the harder they are to upload. So I'm going to probably leave it like this for you to finish. Remember that at the end, you want to write your integral in terms of x.